All right, let's keep going. So we got some more freefall problems. Now we're going to do number 2. Okay, I'm just using this and this to cover up the rest so we don't have too much in our eyes. So let's look. Number 2 reads as followed. An object falls from a high building and hits the ground in 9 seconds. Ignoring air resistance, what is the distance that it fell? So let's highlight what we got. 9 seconds. And let's circle what we need to find, which is distance. Okay, so we're going to write down on the side what we got. We have time equals 9 seconds. We have initial velocity equals 0. And we're looking for distance. Okay, so there's 2 ways we can do that. Oh, excuse me, we also have gravity. I'm sorry, because it's falling, so gravity is 9.8. Acceleration A equals 9.8 meters per second. Okay, as I said, there's 2 ways we can do this. We can do this the easy way, or we can do this the hard way. They will both get us the right answer. One way is like a shortcut to the goal, and the other way is the long way where we have to use an extra formula, which will also get us the correct answer. The first part of this video, I'm going to show you the, I guess, quote, shortcut, right? Even though it's not really a shortcut, it's just the normal way. And then the second part, I'll let you know, and you can turn it off or stop, or keep watching. Hopefully don't get confused and find the other way. So again, I'm going to look at my formulas, and based on what I'm given and what I need, I'm going to choose the right formula. So what do I need first? I need distance or displacement, right? When I look at this acceleration, because they also give me time, initial velocity, and acceleration, I'm going to look at these 2. Actually, these 3. Time, I need to find displacement and initial velocity. So in this one, I don't have final velocity, and there's nothing for displacement. So like it doesn't tell me exactly what I need to know, and I don't know this. So I'm not going to use this one. This one, there's the distance or displacement that I'm trying to figure out, but it also has a spot for final velocity, and I don't know that either, right? It doesn't really tell me velocity. So this one is not really the best one, because again, there's 2 things that they don't give me. Let's look at this one. I need displacement. They ask for initial velocity, which we have right here, 0. They ask for time, which we have right here, 9 seconds. And then they ask for acceleration, which we have right here. So this one is everything I need. So I'm going to use this formula, okay? You could go about it using these 3. And you'll have to go through one, figure out something that you're missing for this one, go through this one, figure out something you're missing, and then find the final answer with this one. It's kind of a lot of steps. And if you want to do that, it's fine, because I did that a second ago, and I made sure you could find the exact right answer. But I'd rather not. I'd rather do one formula, one shot, one answer. So let's write down the formula. So we're trying to find distance or displacement. So our formula is displacement equals initial velocity times your time, parentheses just means times, plus, I put this in parentheses, I'm going to put a little dot on the top and bottom of my time. This is time, okay? This is plus 1/2 the acceleration times time squared. Whew, that is a lot of stuff, right? So we're going to go straight up right below it just to conserve time. We're going to plug in what we got. So distance equals my initial velocity. Well, it just got dropped in the building initially. Before it gets dropped, it's 0 times time. So it's going to be 0 times 9 seconds. We already know what that's going to equal. Plus 1/2. Remember acceleration of gravity, 9.8. So 1/2 times 9.8 times time squared. We know that time is 9 seconds. squared. Okay, so this is 1, this is 2. Okay, now let's do what we can do. So distance equals 0 times 9 is 0. I'm taking that out completely, so I'm not even going to add that into this side, okay? I'm going to square this first. So 81 times 9.8 times 1/2. Okay? Now, we're going to do 1/2 times 9.8 times 9 squared. So I'll give you guys a second to do that. So you should have done 81, because 9 squared is 81, times 9.8, which is the acceleration, times half, and you should have gotten 369.9. So our distance equals 369, excuse me, I messed up. I switched that. 396.9. Okay, said that backwards. Meters, right? So that's what the answer that you should have gotten, okay? That is your final answer. That's awesome. Stop here if you don't want to hear any more. If me telling you more will confuse you, just stop. Because everything I'm going to say now is just extra, okay? So you don't need to hear this. Okay, here we go. So I'm going to keep going if you were to want to do it the long way. So looking at our formulas, I'm going to have my sheet that just has a bunch of chicken scratch on it. So again, they gave us time, initial velocity, and acceleration. So if you wanted to do the long way, you could do this formula here, because you have this, this, and this, and you don't have this. And you could figure out our final velocity. So if you did that, there's all my paper here. I'm going to fold my paper a little bit. So I would have done something like my accelerations here equals final velocity, which we don't have, minus initial velocity, which is 0, divided by time. So if we multiplied, let's see, got this multiplied by 9, our final velocity is 88.2, right? So that would tell us our final velocity. Then we could go to this next one, right? Now we have our final velocity, 88.2 squared, which is going to be a huge number. It's going to be, let's look at my more chicken scratch. So 88.2, let's see, acceleration is 9.8. Where are we? Here. 9.8 equals 7,779.24. Initial velocity is 0. Divided by twice the displacement. So on my sheet, you should be noticing, hey, well, this is supposed to be acceleration, but you have 19.6. Well, that's because what I did is this 2's underneath it, so I multiplied by 2, which cancels this out. And then I had to multiply acceleration 9.8 by 2, which is 19.6. So now that we have 19.6 equals 7,779.24 divided by the displacement. And in this case, we multiplied by d, multiplied by d, so the d cancels out over here, and then divide this 19 out, and then so it's 7,779.24 divided by 19.6, and that gives us our distance of 369.9. So as you can see, this second way, we had to go through 3 formulas to get this. Our first way, we just went through 1. So could we get it either way? Absolutely. Would I rather go through 1 formula instead of 3? Absolutely. Okay. So hopefully you didn't watch that and get more confused. Hopefully you stopped if you get confused. And if you didn't, well, now you know there's 2 ways to solve a problem, right? So, all right, guys. So remember, with these formulas, look at what you know, look at what you need to know, and look at the formula that will get you there. Math is it's flexible in terms of the formulas you can use, but there's also only so many ways you can do it. So you know if you have what you need, you can find everything you need beyond that. All right, guys. Good job.